All right, so here is an extra example of finding the zeros of quadratic equations. Example 1. So, find the zeros of the following function. Y is equal to 5x squared. Look at that. The squared bit is y. This is a quadratic equation, right? Minus 12x plus 4. All right, so how are we going to find the zeros? Well, the first step is to factor. So I'm going to factor this quadratic. And how do we factor three-term polynomials, quadratic polynomials? We're going to factor them with the AC method. So I'm going to take my A, it's 5, and my B, 4. Multiply them together. 5 times 4 is 20. I'm going to find the factored pairs of 20. What are the factored pairs of 20? I always like to start with the number 1 because number 1 is always a factor. And the other factor in that factored pair is always the thing itself. So 1 times 20 is 20. And then I'll just move up. Is 2 a factor? Yes, it is. 2 times 10 is 20. What about 3? 3 is not a factor. 4? Yes, 4 is a factor. 4 times 5. And then once we've gotten to 4, the next factor is 5. But we already found that one, so we've kind of hit the end of that. But I forget. We also have to think about negative factors. So is negative 1 a factor? Yes, negative 1 times negative 20 is positive 20 because two negatives together are positive. When you multiply them, negative 2 and negative 10 and negative 4 and negative 5. Okay, so I got to remember my negatives too. Now, which of these pairs, if I add these pairs together, is going to equal my B? And what's my B? It looks like my B is negative 12 in this case. So what about this first one? 1 plus 20. 1 plus 20 is 21. Nope, not negative 12. 2 plus 10 is 12. Oh, well, we got the right number, but again, wrong sign. Our B is negative 12. What about 4 plus 5? That's 9. Okay, so all these are positives, and that makes sense because all these numbers are positive. So we really should have been looking in the negatives this whole time to get a negative number. So negative 1 plus negative 20 is negative 21. Not quite. Negative 2 plus negative 10 is negative 12. Oh, perfect. That's our B. Okay, so negative 2 and negative 10. That's the pair that I want. All right, well, what am I going to do with that pair? Well, I'm going to take this equation, and I'm going to write it again. I'm going to write the same equation. It's the same, so I've got an equal sign connecting because they equal. But instead of writing it exactly the way it was, I'm going to take that second term, the B term, negative 12x, and I'm going to split those negative 12x's up into negative 2 of them and negative 10 of them because I already said that negative 2 plus negative 10 is equal to negative 12. So let me take that negative 12 and write it like negative 2x minus 10x plus 4. So I rewrote this equation, but now with 4 terms, and I got the extra term by splitting up that B term. Now I'm going to, since I have 4 terms, I'm able to now use grouping. So if I group the first 2 terms together in a parentheses and group the second 2 terms together in a parentheses, always putting a plus sign between my groups, then I can find the greatest common factor of both groups. So in my first group, I'm looking at that. Okay, the greatest common factor, it looks to be x. Okay, because x can divide evenly in both those terms, but nothing bigger than x. So if I divide an x out of both those terms, I'm going to be left with 5x minus 2. Okay, now what if what's my greatest common factor in this second polynomial? Well, it looks like to me that a 2x not 2x, just a 2 divides out of both. I'm going to divide a negative 2 out of both. Why am I dividing a negative 2 instead of a positive 2? Well, if I divide by a negative 2, the signs change from a negative 10x to a positive 5x, and from a positive 4 to a negative 2. And because the signs change, now I've got matching factors in both sides of the equation. And matching factors are important. If I had just divided a positive 2 out, the factors would not have matched. The factors need to match because I need to be able to divide 5x minus 2 out of both sides. That's why it's got to be there in both sides. If I do that, I'm left with an x minus 2. So there's my factors. That was the first step, is finding my factors. Okay. So now that I've found my equation, I've figured out a way to write my equation, not as a quadratic function anymore, but as a product, that's a multiplication of two linear functions. Now it's really easy for me to find my zeros. Remember, a zero is the x values when y is equal to 0. How is it easy to find my x values? Well, since I have two linear equations multiplied together, and since when you have multiplication and the answer is a 0, all you need is one thing or the other thing equaling 0, then I can set each of these linear equations to 0 and solve them each separately. So let me solve them each separately. I can add 2 to both sides, and I've got 2 is equal to 5x. I can divide both sides by 5, and then I've got 2 over 5 is equal to x. There you go. What about this one? Well, this one's even easier. I can add 2 to both sides. I can add 2 to both sides, and I've got x is equal to 2. So x is equal to 2, and x is also equal to 2/5 when y is equal to 0. So I found my zeros, my x values when y equals 0. So my zeros, what are they? 2/5 and 2. And there's my answer.